This is Mary Ann Lindsay and Andrew Gibson presenting the process improvement of an emergency department patient radiology order to patient disposition, which is basically the radiology part or the x-ray part of the emergency department patient visit. And what we'll be doing is basically providing an overview of the process we chose to study and how it fits into this overall system, such as issues of waiting times, potentially wasted revenue use, and how it's critical to the overall experience and fits into the system. Next, we'll map out the way the work is currently done in the current state map. Then we'll look at identifying the problem areas and what we're going to be trying to resolve or improve. Next, we will discuss our approach for assessing these issues and solutions and how we're going to approach the corrections. Then we'll circle back around to a list of areas for potential process map changes, focusing on the customer or the patient and how these changes could affect their experience, service, and outcome. And finally, we'll wrap up to summarize how this improvement process will benefit the organization and the system as a whole. So to start off with, I want to emphasize again that we realize this is part of a bigger process or a bigger system, which would be the patient flow through the emergency department. The process is a constant challenge with a variety of inefficiencies and downtimes, and the flow of patients is equivalent to the flow of product and the production of revenue. The process involves multiple personnel, procedures, conditions, tech interfaces, monitoring times, evaluation times, and of course, clerical processing. There are many gaps where the patient is simply waiting for the next step. And this is, of course, not generating value to the customer or the organization. And this is just a general overview of a skeleton ED visit. This is the system we're actually working within, and the highlights are the wait times. This, again, does not add value to the product or the ED visit in our circumstance and does not generate revenue or patient satisfaction. The improvement in the efficiency of the ED throughput or the emergency department throughput is a high priority for multiple stakeholders, including patients, family members, physicians, nurses, and hospital administrators. An improvement in this process will help our time goals. And these are I've highlighted two of the most important metrics which are measured, which are, of course, total ED time, which our goal is less than 3 hours average, and the door-to-doctor time is less than 15 minutes. And of course, aside from improving our metrics, we will improve patient satisfaction with the process if we can hit a couple of goals and improve some certain factors. Also, what we're looking for is to prove our clinical outcomes. In many cases, an efficient, well-timed radiology test the result specifically drives a clinical decision and critical treatments that are well known to affect patient outcome. The difference can be between a very functional return to lifestyle, disability, and even death in some circumstances. We will be looking at the part of this bigger system and the process we are specifically going to be studying is the radiology process, specifically getting an x-ray study done on a patient. And this influences their clinical treatment plan and, of course, their ultimate disposition from the emergency department or admission. And we've got a lot of complaints to address. There are complaints that it takes too long, and that's both from the patient side and the doctor side, our internal customers. And we need these results to make a treatment decision. So we may be holding treatment or holding a decision on the treatment based on the results. And we need the results to disposition the patient, which will get them out of our system and make the product or the well patient. And we hear the labs are back, but the x-ray's still not been done. We hear that the x-ray's been done, but the radiologist never received the images, so they can't read it. Or we have the radiologist, the doctor who's reading the x-rays, backed up, which is a point of a backup in our system. We have staff sitting around potentially waiting to do something or playing on their phones, and that's lower productivity. We can't sell the time that we buy from employees unless it's actually generating a valuable piece of the revenue. And we have technically qualified staff that are doing non-technical tasks that we could pay someone else to do and get them on the actual production of the revenue they were hired to produce. We have a current process map, and I'm going to zoom in so we can explain how we approach this. But the current state map is going to start at the top, and I'll just zoom in. the physician evaluates the patient and puts an order in the physician order entry. And this puts the order in the Epic system. The Epic is the electronic medical record. The nurse then sees the order and acknowledges this as well as all the other orders. And the radiology tech can also see this order on their screen, but this is not a green light to perform the study. They're waiting for the go ahead. The nurse completes the nursing orders, which could be medications, drawing labs, getting things started. They get those sent off to the lab. And there's actually a reason why there is a hold, and that's because the labs typically take longer to process in our system. But of course, this process is not considered in isolation, and no process should be. But that's why there is a delay. But when the nurse has already completed those orders, they will then in turn click this ready button in the imaging box. So they actually go to a little box that says the radiology status, and they change it to patient ready. And that's the go ahead, the green light for the tech to come and get the patient. This brings the patient into the radiology tech's queue. This is work in progress for the radiology tech. So there may be this plus many other studies. These are people waiting, ready to get an x-ray and waiting for the tech. And the tech will come and get the patient from the emergency department room and take the patient over to radiology to do the x-ray, perform the x-ray in radiology, and then they'll push a complete button, which actually signals that they're finished with the study, because an x-ray could involve 6 or 7 films in a plain film, and certainly lots more in a CT. And then this is all the radiology process or the x-ray process in process. There is a delay here, a potential error, because when the tech comes to get the patient, if they're not in a gown, they have to stop and put them in a gown. And this is certainly not what we want to be paying the radiology techs to do. At the end of the series, they push this complete button. What this will do is send the actual completed x-ray over to the software in McKesson, which is the radiology reading software. And this is now in the process or in the lineup to be read by the radiologist. So there's another delay here while this work in progress piles up for this doctor to interpret. We may wait for this reading from 10 minutes to over 2 hours. It depends on how long it took the study, how complex the study is, whether it's a plain x-ray with 1 or 2 films or a CT with maybe 30 films. And there are lots of theories on what determines this variable, but this studying this variable would actually be very helpful. The radiologist then looks at the x-ray when he gets to this study, dictates a report, and digitally signs the report, which sends it back into the Epic chart, which is the electronic medical record, and changes the status on the board to complete. This is now in the queue to be reviewed along with the remainder of other lab work in the emergency department physician's work to be done pile. And then there's a delay. It sits there not having anything done with it until those results are reviewed. And then, of course, the physician makes a treatment decision, and discusses those with the patient, and the patient is dispositioned, which is the endpoint of our evaluation. So when we assess this process, we looked at several variables. The goal of our service process design is to create an exact combination of equipment, labor, software, work methods, and environment to produce a service. And this service is our product. The product is the interpreted studies that we're going to act upon to make a clinical decision and a disposition. Everything we do should add value in this process in some way. And process design, it can affect many things. So depending on what we manipulate, we can affect, improve cost or profitability. We can improve flexibility, which is important in the emergency department because we have a lot of change in demand. We have ebbs and flows, and that's not predictable. And we also affect quality of care. We need high quality images. We need them quickly, and we need them interpreted by a board certified radiologist accurately. And so we used the theory of constraints as developed by Elio Goldratt in The Goal, and looked at this process closer. There are a few things we did not consider in this process. We did not consider breakdowns, malfunction, or downtime in either the x-ray equipment itself or any of the servers. We also did not consider that there might be a pandemic, because that involves any number of problems with PPE preparations, contamination, outage of CT scanners due to 30 minutes required to redo the the cleaning process for a contaminated CT scanner. We also are going to assume that we have great people. One thing the theory of constraints looks at, the first thing, is the bottlenecks. We identify constraints or bottlenecks in the process. This is where the pile up of work occurs. It's work in progress in queue for the tech to come and get. These are x-rays waiting for techs to process and actually perform the x-ray. We also have another bottleneck where the radiologist is interpreting the film, and we have a third bottleneck, big bottleneck, which is where the emergency physician is reviewing the result to act upon it. We can liken this to an example given in the book by Goldratt, published in 1984, where he compared this to a Boy Scout troop hiking. And what the primary character in the book realized was that you're looking at this line of a process, and there are certain things which control the speed of the line or how fast you get to your destination. And if you have a slower boy walking in front of someone or in front of the whole line, he will control the speed. So they're not going to be able to go any faster than the process in front of them, but they can slow down. So while they cannot go any faster than some process in front, there would be any number of varieties or variations or fluctuations in their slowness. So we looked at it, kind of comparing it to that process. But just going faster, the bottleneck's not the answer. We have to go back and ask, what is the goal? And the goal is to increase productivity, to decrease turnaround time, and to theoretically take care of more patients and take better care of those patients. At the same time, we need to use staff, which for a service industry could be considered inventory, because we buy time from employees, and we can only sell the part of their time that's doing a value added activity. Also, we have goals for trying to maximize the productivity of our machines. A machine just sitting in the hall waiting for performance is not productive. So we can never just determine the precise number of patients, and that's a huge variable in the emergency department evaluations or any of our processes there. These are statistical fluctuations. We can probably figure out how long it takes someone to actually perform the x-ray or the CT. We can have a bunch of different numbers on that. We could also study the most efficient way to send the studies to be read by the radiologist. These activities can be maximized with efficiency, but it is difficult to impossible to change or flex up to a faster speed in three of the most important bottlenecked areas. So we are interested in three main pieces with evaluating our bottlenecks, and that's that we always want to be looking at a higher throughput, which is the rate which the system generates money through sales in a production plant, but it has to do with the rate of patient, how many patients we see in the emergency department. We're also concerned with our inventory, whether that be things that we sell or people's time that we buy, and operational expense, what we're spending on the system to allow it to turn inventory into throughput. And this operational expense, when we have an employee not maximally productive, their time that we're buying for them turns into an operational expense if we're not using it for valuable production. And certainly our delays do not add value. We know that for a fact. So when we look at our future state map we've proposed, there are several ideas we have for improving the process. The first of these, we're going to zoom back to the front part of the process and taking some of the x-ray order back to the front part of the whole emergency department visit, even in front of where a doctor would put in an order. If we could develop part of the system to have these orders actually entered almost immediately upon arrival, which could be done with simple x-rays. If you come in and you hurt your hand, the triage nurse knows what we're going to order. This puts them in line much sooner, and it's also a simpler study to be read that could be read more quickly by the radiologist. Then we're also going to look at the use of non-clinical staff. One part we could do this is when the patient's brought back to the room, this is where they should be put in a gown, not even waiting for the nurse to put them in a gown later. And this would eliminate some of the backup and the delay that radiology techs have complained about, that the patient is not in a gown when they come and get them for the x-ray. We could also use non-clinical staff to transport the patient to X-ray. So when they're in queue for radiology, rather than having that radiology tech walk all the way to the emergency department and then take them all the way to the back over to their department to perform the study, we could actually consider using non-clinical staff. We already talked about eliminating or decreasing the amount of patients who are not in a gown. The other thing we could do is go to moving some radiology equipment as it's feasible to the emergency department. We do have portable x-ray machines, and we use these frequently for patients who are getting portable chest x-rays, but we could actually back up and use that equipment more often to where the patient didn't have to physically leave the emergency department to have the study done. There is a huge problem with an error back here where the radiology tech has finished the exam, they finished performing the x-ray, and they must push a complete button to send the radiologist the x-ray reading. That button is consistently or frequently missed. And it would be nice for IT to help us find a way to make a hard stop there to where the complete button for some reason has to be pushed. Or that after a certain amount of time has passed, perhaps they realize that the x-rays are finished putting into the system, that it would automatically send it to the radiologist work-in box. There is also an area here where the radiologist interprets the x-ray, dictates the result, and digitally signs the report that becomes backed up. And this is the delay. We're waiting on the reading for the radiologist, but the study's already been done. And there are several ideas that we had for this backup. And one is to talk with the radiologist and develop a surge plan, either through outsourcing to on-call radiologists remotely, or we could figure out how to make their work more efficient. For instance, assign certain radiologists quick and easy, quick studies to read, and other radiologists could get into a flow of reading longer, more complex studies, and that would perhaps improve our efficiency. Or develop a way with IT to place these an accessible screen in the area where the emergency physicians sit, so that they may be able to access the x-rays themselves and disposition patients based on their preliminary readings, which could be followed up by a confirmatory reading from the radiologist. So there's some ideas we had with some of these highlighted areas, which would be difficult, probably would involve a whole project plan in itself. But that might help our system become more efficient, or at least improve significantly. The other thing is there's a delay in the time that the x-ray has been read by the radiologist. It's sitting in the electronic medical record, and the emergency physician has not seen it yet because they're not getting around to catching up with their work pile. And we could recruit and train their nurses to identify potentially like just a hit list of critical results or quick results, which they could maybe help expedite by putting a note in the chart for the physician to see a little more readily than waiting till they dig into the chart and see the final radiology reading. So what benefits would our couple of improvements be to the system? Well, we would potentially be able to get, with our expedited order from triage, we could save about 5% of patients a little bit of time and get them to the radiology waiting line a little quicker, rather than waiting for the physician to actually assess them, then go back to their workstation and input the order and wait for that whole triage process to go. Also, we need to work on freeing up our radiology techs to actually take the x-rays, because that's where they're adding their value. So getting patients into the gowns earlier when they first come back to the room, that would at least give another alternative way to back up that the patient was definitely in a gown and definitely ready for x-ray when they're marked ready by the nurse. And we could improve certainly productivity and what we're spending on radiology staff. So to summarize, we primarily use the theory of constraints to evaluate the radiology process of the emergency department experience, which allowed us to focus on points in the process map where constraints or bottlenecks led to delays or have been leading to delays and inefficiencies. And we focused on removing some activities which were not value producing. And these were some of our references. We thank you for the opportunity to participate in this challenge for operations management, mba516.